The 6th Annual Assembly of Planners Symposium, combined with the Pacific Risk Management Ohana, or PRIMO, was held on August 18th and 19th, 2021 at the Dusatani Guam Resort and was brought to you by the Bureau of Statistics and Plan's Guam Coastal Management Program with a grant from the National Oceanic and Atmospheric Administration. This two-day symposium was a hybrid conference, hosting live, in-person, and virtual attendance via Zoom. The theme of the symposium was Perseverance, Building Resilience, and Navigating the Way Forward. Up next, Session 3, Zero Waste, a food recovery update, facilitated by Mirko Agostini, Executive Chef of the Hyatt Regency Guam.
So to kick off the zero waste discussion, we're going to start with an update on the food recovery program, which was something that is incredibly ambitious, had a little bit of a setback because of COVID, but we're looking forward to having that moving forward again. I'd like to invite up to the stage Corey Heinz, Lourdes Hongye, Leilani Navarro, and Mirko Agostini. And to lead this off, Corey Heinz is the Jacobs Project Manager for the development and implementation of a sustainable materials management program for Guam. With 25 years of experience in planning, design, and construction administration, as well as solid waste, wastewater, transportation, site development, and facilities. Mr. Heinz has developed a reputation for developing practical, cost-effective technical solutions that are tailored to the projected need. He has direct experience in sustainable materials management, landfill design, construction and operation, and biosolids composting. He has personally worked on this Guam food donation project for the last 2 years. Ladies and gentlemen, Corey Heinz.
Good afternoon, folks. Thanks for hanging in there. We're excited to give you an update on our program here. So I'm going to introduce our panel here today. We have Mirko Agostini, the Executive Chef for the Hyatt. We have Leilani Navarro, the Acting Environmental Public Health Officer Administrator for the Bureau of Inspection and Enforcement, Department of Public Health and Social Services. And we have Lou Hongye, the Program Coordinator for the Salvation Army Lighthouse Recovery Center. Mirko will take the first couple slides. Come on up.
I just want to say good afternoon, everyone. And I just taken from the point of Hyatt, as I've been working for Hyatt 25 years, and as an executive chef, I see every day, you know, we provide for many people, which they come into our house for to get the food, yes, and they pay, they do everything. But on circumstance, all the time, we have some extra food. And we are at the Hyatt, I repeat, we are already working as a zero wastage. What does mean a zero wastage? Especially in Guam, I have the message, whatever is the food coming through a plate or whatever is coming from the table, whatever is left, which is being contaminated, is going to a pig farm. Yeah, we try to avoid just the little of contamination where is a little plastic and a paper, which there is a food residue is going to the trash. But 99% of the food, even the team when they clean it up, the plate is go to the bin, which is gonna be the pig farm, which is every night they're gonna come in and take it to feed this pig. The next step is to going to say what we prepare and on circumstance, like a function like that is going from preparation of 200 people and they show up only 100 people. We cannot be unprepared. We must have the food for 200. And when we come into the point, we will have a space to use as our people the next shift or whatever it can be used as for that. We will use it first, but there is always a point which we have an extra. And meaning is a safe food and it's been keeping safe as the food. What we can do, yes, if we trash it to the bin as the pig is just gone in their zero wastage. But if there is hungry people, why we are not going with the support of public health, with the support of Salvation Army to make sure it's not because they're hungry we want to give it food which is not right. They are hungry, we want to give it the food which is right instead to go into the zero wastage. I don't call anymore because I comparison as the farm to people. No, is to just to have an extra step and an extra vision to say instead why this food it came from far or wherever it came from, is going to feed an hungry person. And that's where we created this system. We've been slowed down just a bit because COVID closed. Now, as we start to reopen the place, we want to restart to say, let's do it. And that's where we came across to prepare ourselves. And here is my 3 slides as I presented is, can you want to go to the next? This is the 3 pair people, which is Hyatt, as I say, zero wastage that way, as Hyatt, Public Health, Salvation Army, and that's where is the place where I go. Let's go to the next, okay? As I just saw, I just say in my 3 note, we want to do it in the right way, meaning a control of temperature and right cover and right date and all of this, which is the food is required from public health have to be done. Meaning that's, and is not a consistency provider, but Salvation Armies agree with that one to say, as much we give it the lead, the chef over there, he will not cook, he will be saved the raw material for the next shift. And he's used whatever he needs to be used first. Next slide. Okay. As this was the first things I say as a Hyatt, we start as a 2014 to support the sustainability. We have a big branch of the seafood sustainable. As we are an island and we are in close to the ocean, we must take a goal of to continue to as well serve a sustainable seafood. And the other branch is to try to use what is available first in the place where we are. And the third one is to try to branch out to have a link to reduce the waste on food. Next slide. And I'm done, and I introduce Lou. Thank you.
Good afternoon, everyone. As mentioned, my name is Lou. I work for Salvation Army Lighthouse Recovery Center for 13 years. After I retired from Guam, I went to nonprofit. So anyway, let's look at the slide. I just want to let you know a little bit about our Salvation Army Lighthouse Recovery Center. We provide residential treatment. We have at least, we can house 30 clients at the most, but on an average, we house about 20 and provide food for them yearly, about 22,000 meals a year, because we provide them with 3 meals. Okay, that's the residential treatment. We do have the outpatient and inpatient, the outpatient and intensive outpatient treatment. They do come and eat sometimes, you know, when they're hungry. We do, when they come in for counseling, we do provide food for them. We also have our, at the time, it was called social detox, but now they have a new name. They're better known as withdrawal management. These are the clients that come in to actually get detox for whatever drug they're using. Then we provide groups. We have numerous groups. We have the adjustment groups, moral recognition, helping men recover, and driving with care. Driving with care, education, and therapy are those that are referred from the court because they were caught driving and drinking, okay? So they're there for therapy. Besides what you see there, I mean, we do have the family education. During the COVID, we didn't do any of these groups, and the continued care. We also have the USPO drug testing. What it is clients from the United States Probation Office come in to do drug testing, and we have about 250 to 300 clients 250 to 300 drug tests, not clients, that we provide the USPO clients. What it is, the way the USPO drug testing goes is that it's like the jury. When you're in jury duty, you call in and you're supposed to have a color, and then you come in for drug testing. Some of the clients come in about 6 times, so the numbers are not the clients, but how many drug tests we provide. During the pandemic, I think the next screen, please. Okay, this is only for 2010 to 2018. We have numbers for 2019 to 2020. We provided 440 clients with our various treatment services. But again, these are clients some of these clients we don't feed, We only feed the residential, those that are in residential, and some outpatient. Oh, and social, the withdrawal management, because they stay with us for a max of 14 days. And then sometimes they move up to the residential treatment. During the pandemic, when March 16th, we had 15 clients that were in-house, and they were locked down for almost a year, I guess, till we got the governor loosened the restriction. We did take them out for beaches and hikes and, try to get them outdoors and everything. But those 15 eventually dropped to 12 because some of them were discharged. So the 12 stayed with us for a longer period. We never stopped helping clients because we're a health facility, so they were coming in, getting assessment, and we were practicing our safety measures. We also never stopped drug testing. It continued towards, it never ended. When an client comes in for residential treatment or withdrawal management, they had to go first, they were assessed, and then they had to go to GMH, get their rapid testing, and then come in, and then they were quarantined for 10 days. The clinical staff they were certified in telemed, so they provided treatment to the intensive outpatient and the outpatient. I don't know if you guys know that in 2019, we were awarded. Okay, we were awarded the Women's Treatment Center. So we are waiting for that. As soon as the contractor gets all their workers together, it will start going. We had a groundbreaking on March 31st, but they never started. Okay, the facility for the women's treatment, we're going to provide at least 12 beds for the women. The food recovery. Prior to COVID, we received the trays and the carts to transport food from Hyatt to LRC, and plans for this program, were proceeding. We were supposed to have an inspection of the kitchen, then COVID came, right? Sometime in June, Corey resumed the group, and we had a meeting. And I guess the next step for now is the inspection of our kitchen, training, dry run, and the completion of the MOU. Wanted to say that we are committed to move forward to this program, and of course, with compliance with the Guam Food Code. Thank you. Sijus Masi.
Good afternoon, everyone. I'm here to present on what the team is planning to do to ensure the safety of food during the transfer. So during the pandemic, the team remained committed to continue with this initiative. As the new Food Safety Program Manager of the Department of Public Health and Social Services, or DPHSS, I was assigned to assist the team by providing guidance based on the Guam Food Code. Next slide, please. The Guam Food Code is the regulations that apply to eating and drinking establishments on island. I met the team for the first time on June 23rd, 2021 at the Salvation Army office in Tijan, where we discussed the next steps for this project. As a result of the meeting, a draft Memorandum of Understanding, or MOU, between Hyatt Regency Guam and the Salvation Army was finalized. As you can see in the picture, food trays and insulated boxes for the transfer of food from Hyatt to Salvation Army were purchased, and assessments of the food operation of Hyatt and Salvation Army have been scheduled. Next slide, please. The MOU included specific details to ensure the safety of food. For example, a labeling system will be implemented by Hyatt to indicate the date and time of food preparation. Salvation Army will be responsible for deciding the holding time for each received food and whether food will be kept hot or cold in accordance with the Guam Food Code. Next slide, please. Moving forward, DPHSS will conduct food safety inspections and assessments of Hyatt and Salvation Army. Hyatt and Salvation Army will sign the MOU, and a dry run of the operation will be conducted by November 2021. Thank you.
Okay, thanks, guys. So now, just to wrap up here, our vision for the future is that this is only going to be a model for what is possible here on the island. The vision is that there will be many of these partnerships that will be stood up. We're looking now for other hotels who may have some excess food from their buffets to use our program as an example to move some food to another nonprofit. So if there's anyone out there from the Dusit that's listening, step up. Find yourself a nonprofit, ask for a draft of the MOU, and ask for some advice from Leilani. We're here to help and make it happen. So we're also looking forward to the next phase, which is to sort of increase the scope of this food recovery to include the development of what we're calling a food bank co-op. So the idea here is to increase the scope to not only be the retail, the hotel, but to include the importers and the wholesalers and the retailers. And so this vision includes a facility that would be on government land, and it would receive food that is perhaps getting close to expiration, perhaps just after expiration, but it's still good, edible food, and make this available to folks in need. So this is sort of we haven't completed our planning on this, but this is where things are going in the future. We see this as a partnership between government and the private sector, and perhaps some tax credits would be available. So if folks have any suggestions on this or contacts that we might be able to use or access, we'd be welcome to hear about them. Thank you very much.
Up next, Session 4 on Zero Waste on Biosolids Composting. Facilitated by Conchita Taitano from GEPA and Todd Williams from Jacobs Engineering.
I would like to invite up to the stage our next two presenters, and that would be Conchita Titano and Todd Williams. Conchita has been with the Guam Environmental Protection Agency for about 29 years. She has worked as the Air and Land Division Administrator for over 22 of those years, overseeing the air program, pesticides program, hazardous waste program, and the solid waste program. Conchita received her Bachelor of Science in Biology and her Master of Science degrees from the University of San Francisco. She studied environmental and sustainable development at the United Nations University in Tokyo, Japan. And she also studied environmental policymaking at UNESCO Water Institute in the Netherlands. And beyond that, she is someone who has really dedicated her life to the environment on Guam and to the zero waste predecessors, as well as to the program as it is today. So now, without any further ado, ladies and gentlemen, Conchita Titano.
Thank you, Ginger. Thank you for that generous introduction. I'd also like to thank BSP, specifically Tyrone Titano and Edwin Regis, for inviting us again to provide an update on our work on zero waste. I'd like to introduce Todd Williams. Todd is a compost expert and recognized nationally and internationally. Todd is the past chair of the Water Environment. Hey, I knew I was missing something. There we go. Oh, there we go. Okay, Todd is the past chair of the Water Environment Federation's Residuals and Biosolids Committee, and he currently serves as the Jacobs Engineering Residual Resource Recovery Global Technology Leader. Todd?
How's everybody doing? You ready for this? So we talked about this pilot demonstration work last year in February, and so this is going to be a little bit of an update with some new information. There was a number of folks that were involved in this project. If we go to the next slide, you'll see some of the people that were involved. Was there anybody in the room that represents any of these organizations? If you could please stand, because there was a number of folks here. Is anybody out there? Yep, we got some over there. We got anybody else? So thank you to everybody that participated in the development of this demonstration project. A lot of people that put their hands to the plow, so to speak, and so excited to talk about the results that we have and where we're moving forward. So next, we'll go to the next slide and we'll start talking about it. I think you guys probably know, but there's a number of, there's actually a master plan that was done a number of years ago, and there are a number of water resource recovery facilities around the island, but two of them are the largest and make up about 95% of the wastewater treatment. And the residuals from those are largely in the north. You have the northern plant, the Hagatna plant, and then they go to the landfill way down south. So it's a really long ways to haul this material, and it's natural to look at doing something else with it instead of it going to the landfill. So next slide. We'll keep on going here. So the demonstration project goals is to measure all the input materials. We wanted to use waste pallets as a bulking agent. Why is that? Because Guam is has a lot of waste pallet material here. Everything gets shipped in. And so there's a lot of that material that is a resource for our composting, and it's a match with the biosolids, or the wastewater solids that are wet, with the dry bulking agent. It provides all sorts of benefits to put them together and compost them. And it takes care of two waste problems at one time. So what our goal was to demonstrate that through this process, we would meet all current US EPA standards for the highest quality biosolids product that you can make. Then we wanted to do some use demonstrations. So we'll talk a little bit about that. Next. The demonstration details, we took, as I mentioned, the dewatered cake from the two largest plants on the island. 98% of the solids is from the northern plant, the Hagatna plant. We measured the volumes, the densities. We took pile temperatures, and you'll see some data on that. We did about 22 tons of the unprocessed solids and 54 cubic yards of pallets to make a demonstration pile. And if you keep on going next, you'll see, next slide, you'll see what that looks like. So the ground pallets down here on the left, the wastewater solids up at the top. We have an aeration system so that that can be controlled. We mix all of that materials together, place it on an aeration, and then we go to the next slide, you'll see what it looks like. This was the simple demonstration pile. Again, the 28 yards of solids and 54 yards of ground pallets. That was it. And you see the little flags there, that's where we were measuring temperatures throughout the process. Next slide. So one of the first things to demonstrate compliance with the US EPA is to demonstrate that you're maintaining temperatures to kill pathogens. PFRP stands for Process to Further Reduce Pathogens. It's an EPA recognized process to destroy disease-causing organisms. And so you have to maintain a temperature of 131 degrees F for at least 3 days. Then there's also the vector attraction reduction process, which maintains the temperatures above 104 degrees F for 14 days so that you don't have attraction of vectors like flies or rodents or those types of things. So as you see here in the graph, the 3-day PFRP was easily achieved at the 4 monitoring points. We controlled the aeration system. We had to add some water to the process, but we always maintained above that 14 days. So we've met both of those standards without difficulty. And we confirmed that pathogen testing through using salmonella tests to confirm that the destruction was achieved. So successfully achieved the Class A pathogen reduction status and the vector attraction reduction status. Next slide. So that's part of the equation. The next part of the equation is to look at metals in particular, which are considered in the EPA 503 as contaminants. Some of them are actually micronutrients. And so we tested for all of the metals that are on the books and a couple of extra of them. And you see those listed here. And what's interesting is you look at the EPA max concentration, or the EQ column right next to the metal name. You see arsenic's at 41, cadmium at 39. These are concentrations in milligrams per kilogram. And the highlighted in yellow is the Guam compost. And what I'm showing there is the values are on the white column where it says May to 2020. But these values are anywhere from 1% to 20% of the EPA maximum concentration. So it's an excellent material to produce a Class A, now exceptional quality compost. It's kind of interesting and instructive. We look at things, like I said, micronutrients, like look at zinc down there at the bottom. You know, we measured 472 in the biosolids. Look at the Centrum vitamins that you take every day, just as a comparison that you're eating. And EPA is concerned about that. And so there's good science back there, but what we're seeing is that numbers are quite low for this material. On the left-hand side, you see the finished compost product that once we've gone through the process, and the process is basically 3 weeks under aeration. We screened the material, and then we stored it under aeration for another month to cure it out. So why do we do that? So that it'll further stabilize, and it'll be useful when we do take it to grow whatever we're going to grow with. So an interesting piece here, if you look at the bottom, right down there, seedling emergence. We do compost testing. The U.S. Compost Council has these standards that are like above and beyond EPA. And so we looked at nutrients, we look at these other parameters, and the key thing there is that the seedling emergence was 100%. That's pretty unusual for composts from solids from wastewater plants. Usually it's anywhere from 80 to 100%, but we saw 100% growth, which means this stuff is really ready to go for use to grow whatever you're going to grow, turf or plants or that type of thing. There's a bunch of other parameters there that we can get into later if there's questions. But what this tells me as a practitioner from doing this for 40 years, that's why I still have hair, it's been doing this for a long time, is that this stuff is ready for real time to do further testing with. So we'll talk about that next. We went above and beyond here, one of the first actually composting operations anywhere in North America to look at above the standards and look at PFAS. That's a hot topic issue. PFAS is available, it's all over the world, it's pretty much in everything. It's in this carpet here, it's in some of the clothes we wear, some of the things we put on our bodies, it's everywhere. And it ends up going down in the sewer and it goes up into the solids, so it's not something unusual. And we're measuring it at these very low concentrations. So we analyzed at the 24 PFAS compounds at a certified lab, only 19 of those showed up. Why 24? Because that's the standard that the labs are using right now while EPA is developing standard protocols for that testing. And it's normal to see, what you see on the left is what was in the solids, and what you see on the right is what showed up in the compost. And what we see is some increases, which are normal because we get this thing called biotransformation that happens in a biological system with these compounds. They're not creating them, they're just changing from one compound complex to another and becoming more stable. So the concentration levels, as you look at the bottom there, are consistent with what we call non-industrially impacted biosolids or composts. A number of states have done a good amount of research in Michigan, and California is doing some now, and others. And these numbers are pretty consistent with what we would consider to be non-industrially impacted. Just because we can measure them, they're there, but they're low compared to places where they've had problems that you may hear about in the literature or in the past. So we go to the next slide. We analyzed a bunch of stuff. We didn't just look at the solids and the resulting compost. We looked at what was in the wood chips from the ground pallets. We looked at the soil around. We looked at the water that we used in the process, and those were all pretty low numbers. But you can compare this human health regional screening level for soils is at 1,260 parts per billion for PFOA and 1,260 for PFOS. Those are the two most common PFAS compounds that are out there being measured and talked about. And the Guam compost is only about 4% of those numbers. So again, it's not a standard. It's not, from the standpoint of an EPA 503, but it is a human health regional screening level for soil, which is about the only thing you can compare to right now. And the Guam compost is quite low compared to that. Okay? So let's go to the next. So we didn't stop there. Conchita has us looking at a number of things which are really quite cutting edge in terms of looking at what's out there. So we actually did some human health and ecological risk screening, and that's still in progress. We compared these maximum numbers that we saw in PFAS to standards that are out there in the US EPA, in Canada, and in Australia, and we did some comparisons. I don't expect you to read all of the numbers, but we did compare these maximum numbers that we saw in the compost developed to these, and we looked at it from two standpoints. We looked at what was in 100% compost, which is up, I think you can see the numbers, 100% compost or 30%. Why 130? Because typically you're going to blend compost with soil. You're not going to use it straight out. It's too rich for things as it is. And so we looked at it both ways. If you go to the next slide, we're in the process of doing some ecological risk screening where we compared these numbers against soil levels to protect different ecological groups, including birds, mammals, plants, invertebrates. And we're actually taking this conservative risk screening, has shown that the compost isn't going to be harmful for the plants or invertebrates. There may be some impact on mammals and birds, and that's what we're going to be looking at doing some further work and modeling. But the numbers are quite low, as you see here. Next. So what's one of the things we're doing? We're actually doing a bioassay work with worms, because they pretty much are a great indicator. They're like, they're the things that are going to pick up whatever contaminants might be in there. And the reason for that is to investigate this potential pathway for PFAS to travel from biosolids to humans, to birds, to mammals, using worms. And we specifically, and you see in these two buckets, the top bucket is soil from Guam, and the compost is right below it that was produced during this demonstration. And those were sent to a laboratory that does this type of work up in the Seattle area, and they did a number of tests. So basically, we looked at the survivability of worms in various mixtures. And from that work, we just saw some recent results. It's still under review, but the difference between any of the compost blends all the way from 0 to 100% versus the soil that is done with an ASTM process was no difference in terms of the survivability of the worms. So that's a good indication. We'll also be looking at the PFAS concentration, believe it or not, that's in the little worms. So the poor little fellows had to give it up for this, but they're getting analyzed right now to be looked at for what's the PFAS concentration, and then we're going to take that data and it will be used to do human health evaluations and to calculate the impacts on these other areas. Nobody else has done this that I'm aware of anywhere in the world, certainly not in the US. So there's some pretty important work to really dig down to the bottom degree as to what's the potential impact, because of an island nature in particular and other issues. It's important to look at that. So that's in progress. So let's talk about some of the good things that we will be doing with the compost. We're doing some demonstrations with the Department of Agriculture right now. They're doing growth studies, and what I wanted to point out, these are examples here. This is the type of data that we're going to be getting. I had a meeting with the Department of Agriculture yesterday. We've been talking with them for 2 years. Because of COVID, things got a little bit delayed, but we got back on track, and we had a good meeting with Chelsea and her team. And so thank you, Chelsea, for doing that. But what you see here, and what's really important, look at the little blue arrows. Every one of those blue arrows represents compost from biosolids, not Guam's biosolids, so I'll be clear about that. But when you compare it to what else is out there, what's used to grow these things, you see the benefit immediately as to what it'll do. I want to call your attention to the one in the middle with the yellow tags. So you see perlite, peat, ProMix, and then Fairgrow and peat. What are those? I think perlite, everybody knows pretty much what that is and what peat is. ProMix is like the standard that's been used for decades on the mainland US for growing potted soil, or for growing plants. ProMix probably costs about $450 a cubic yard, something in that nature. It's been used, like I said, for decades. And then next to it, you see a biosolids compost mixed with peat. 30% biosolids compost mixed with peat that's next to it. Now, compost in the mainland US sells for about $10 a cubic yard. In island situations, I did some work in Kodiak, Alaska, they were selling it for $50. $4.50, $50. There's an opportunity there for getting a product that can replace some of these materials that are being shipped to Guam, reduce the carbon footprint, make a sustainable environment using waste materials. So these are just some examples of what we will be looking at. Where the Department of Agriculture is looking at about 3 different kinds of shrub, flowering plants, and a couple of different tree varieties. They're going to be doing some tests over probably the next 6 months or so. So we'll be gathering data as we go. So the other thing I'd point out is, what's the value of compost? This is a long list. I want you to highlight just the underlying stuff. What does compost do? Better plant root environment for the plants, so they'll have a better chance of surviving and growing. It improves the moisture infiltration rates and reduces erosion and runoff. Really important on Guam, really important in a lot of places. It reduces water loss and nutrient leaching. This is a concern with fertilizers, is that you put them down there for the plants and then you get some rain events like we have here and it gets washed away, a portion of it. Compost has a benefit of holding that material in the place so that the root system of a plant will take it up. It supplies some beneficial microbes, improves that root growth. It more effectively allows the plant to use those nutrients. The soils can retain those nutrients longer. Again, you're not letting them wash away. They're actually being kept in the soil and available for the plant uptake. This is one of my favorite slides up there on the right with the pictures. This is actual compost produced in Kodiak Island in Alaska, on a similar island situation in some regards. And they planted some seed on that compost that was applied there, and 5 weeks later, this is what you have. So it creates very vigorous conditions for plant growth and for turf growth. So next. So where are we at? The ongoing work's in progress. We finished the demonstration project. We produced the Class A compost. It exceeds exceptional quality standards and the U.S. Compost Council's seal of testing assurance parameters. We're doing the human health and ecological risk screening, and we're going to be doing some bioassay work and completing that work over the next few months. And then the compost use demonstration by the Guam Department of Agriculture is being initiated, and we'll have results of that in the next several months. So we've got one more slide to kind of wrap up. So what are the benefits for Guam? We can divert potentially up to 8,000 or more tons a year that's currently going to the landfill, which would reduce the material going to the landfill by 10%, just by taking the biosolids or the wastewater residuals out, turn it into compost. We can recycle the waste wood pallets that are piling up in a number of locations around the island. It'll help get to that zero waste plan, which is what this is all about. Production of this soil amendment, a fertilizer soil amendment, so that's what it really is, its benefit. It's more of a soil amendment to fix the soils, works to make poor soils better. That clay soil on the south, it'll make it better. The soil to the north, it'll make it better because they're at extremes of soil types. And there's other benefits, the cost savings, the stimulation of local businesses, so there's a lot of potential benefits there. So with that, I think I might be done and ready for, if there's time for questions, and acknowledge Conchita and Corey, who you heard earlier, and the other partners here. So, anybody got questions? Yes, sir.
What kind of content was there of other types of waste, like hair and the other things that are sometimes a nuisance in biosolids?
I didn't hear all of your question.
What kind of content was in this biosolids of things like hair and other kind of nuisance waste that you sometimes get in municipal sewage?
Yeah, so as far as the other material that are in the biosolids or in the solids, they're going to get screened out at the plant. There'll be some that'll end up in the sludge. Beautiful thing about composting, you're running at a very high temperature in the process, and it'll break down any of that organic material to something other. You won't find hair in compost. Specifically. Now, if you don't get the trash out, the trash will come out in the compost if there's plastics or other things that are there. So You go through a screening step at the wastewater plant. You also go through a screening step at the compost process. Okay? Yes, sir.
I see how you did the compost process following the U.S. EPA standards. But have you guys looked at fungal dominant compost?
What, I couldn't hear that part.
Fungal dominant, where,
Oh, yeah.
where you're using basically micro-remediation.
Well, there is fungus in the compost process. Fungus will grow at certain moisture contents. And so we start wet. Fungus doesn't really like that. And then it, as it goes through the process, it'll dry out, and mostly will start growing around the woody material. And there's nothing wrong with that, because it's actually breaking down that woody material into a compost product. So there's a consortium of microbes that's enormous, and fungus is just one part of that.
But there is a way that when you do your composting, as you're going through the finishing process, you can inoculate it, and that's going to help with the breakdown of some of your heavy metals.
Well, we don't have a heavy metal problem here, so thankfully we don't need to necessarily address that. But yes, you're right. The fungus will help break down some of the other materials. Other questions? Come on over. You got one for Conchita?
Are you assured of future availability of the waste pallets? If you need them a lot in the future, will their use be changing in the future that you know?
We don't know the answer to that, the question about the waste pallets. But I'll tell you, you don't need 100% waste pallets into the process. Because once you get them into the process, we're going to recover them and recycle them for probably 2 or 3 uses. So if that goes away, there's yard waste that's here that can also be used as a bulking agent. Yes, sir.
Since biosolids can be used as fertilizer that may be used where grow food that people can eat, are there any studies or evidence that there may be pollutants that are left that can be linked to cancer or any kind of diseases?
Well, we're advocating on this product that it not go to the food crops, that it go to landscaping and to help grow trees, to help grow turf and those types of things. I'm personally not against it going to the food side, but that's the focus of this. Is there so many other uses that you can have for erosion control, for turf, for farming of or horticultural crops? That's what we're focusing on.
Right. Yeah. So the demonstration project with the Department of Agriculture is primarily with ornamentals, right? There's a possibility that we could look into crops, but for the next demonstration project, we decided to start with the ornamentals first. Thank you. Any other questions? Now we're going to close, but I'd like to reiterate what Todd was saying, is that we're doing more than what states are doing with respect to the testing. And then the question you ask is probably why? Well, because Guam is an isolated community. You know, we live here. We just can't drive to the lower 48 like what they do in the States. We're very mindful of the people. We're mindful of our home, and the people of Guam deserve the best, so we're going the extra mile. Thank you.
Thank you very much.
Up next, Session 5 on greening roadway infrastructure, facilitated by Julie Carver and Corey Heinz of Jacobs Engineering and Conchita Titano of GEPA.
All right, well, continuing the concept of zero waste, we've got one more presentation this afternoon. And for that presentation, I'd like to invite up to the stage Julie Carver. And Conchita's going to hang around. We'd like to invite back up Corey Heinz. And of course, with age, I need the glasses. Julie Carver. She's the founding principal of Congruent Environmental Strategies, LLC, a woman-owned small business that provides sustainability and strategic environmental management consulting services to public and private sector clients. Ms. Carver has 35 years of experience working for public and private sector clients on a broad range of environmental and engineering projects. She's a registered professional engineer and a subject matter expert in zero waste, sustainable materials management, and the redevelopment of economically and environmentally impaired properties. And with that, I will hand over the microphone to Julie. Oh, Conchita, okay.
I will kick off. I'd also like to add with Ms. Carver that she is the principal author of Guam's Zero Waste Plan. Let's see, oh, there we go. Okay, so a little background on our work. In 2011, the government of Guam embarked on the development of the Zero Waste Plan. And at that time, it was at a time when solid waste management was, well, the ORDOT dump. So we needed to do something. And many of you have heard about zero waste, or some of you probably integrate zero waste at the home or in the office. But for those of you not familiar with this subject, if there's something I would like you to remember, it is this, that zero waste is a goal. And zero waste is not a linear process. Oh, no, because the next slide is going to be the AIA, right? Yes. So it's not a linear it is not a linear operation. It is a cyclical process over time, and peppered with a multitude of opportunities along the way. And I know that's a mouthful, but our presentations will best show what that means. If we could advance to the next slides. Okay, now I know this is not part of the presentation, but we need to do this because I'd like to remind today's participants that they are eligible to earn a CEU for attending this session. The learning objectives for this presentation include, next slide, those listed. Am I to read those? Nope, oh good, okay. So, for more information, please contact AIA Mariana's representative, Mr. Renato Martinez from HDR. Renato, are you here? Oh, very good. Could you please stand up? There you go. So if you want the CEU, that's the man to say. Thank you. Now we have about 35 slides, so we're going to go over these slides very quickly because we know we have a reception afterwards, and we'll take the questions, obviously, at the end. Okay. The best way to predict the future is to create, and what does this mean? This quote says that the best way to know what is coming is to be an active participant. And by being an active participant, you can help to shape what the future holds. So how is this relevant? Guam's Zero Waste Plan was published back in 2013, and it provided a 20-year master plan to implement a zero waste framework on our island. And it included steps we needed at that time to move forward with a new waste management approach. And as we began implementing the plan, we made adjustments based on data, built next step decisions based on this data, and pushed forward to reach the zero waste goal, or darn well near it. In other words, we acted, learned, adjusted, and we leaned forward. And that's what we're doing the best way possible to create the zero waste future we envision. Next slide. Today's agenda for this session, we will provide an update on our greening roadway infrastructure project, discuss our work with post-consumer plastic, and lastly, share our preliminary study on the use of waste tires in construction application. Next slide. In January 2020, the Greening Roadway Infrastructure Initiative report was published, and greening roadway infrastructure integrates transportation functionality and sustainability concepts using an environmental approach throughout the planning, design, and construction of a road. The result is a road that benefits transportation, the ecosystem, urban growth, public health, and the surrounding communities. Our report is available online in addition to all of our technical memos. It's available online at zerowasteguam.eco. Again, zerowasteguam.eco. The document is downloadable, like I said, and like several of our documents and technical memos at no cost. We do have a simple questionnaire, your name, your organization, and your email, very simple. So we ask that to help us better understand the interests of our audience. Next slide. Traditional recycling. In the initial phases of the evaluation, the GRI initiative report, we looked at various possible waste that could be used to green our infrastructure. We then narrowed our focus to the specific wastes that are produced on Guam, which you see listed on this slide, that could be processed using traditionally used mechanical recycling processes. And what I mean by that is, the sorting, the chopping, the crushing, the granulating, etc. Essentially, these are processes that alter the physical state of the waste, but still preserve the molecular structure. Next slide. The end of the road for plastic waste. I know this is a very big interest for the first gentleman, and rightfully so. Okay, so before we get into the what are you doing and how are you doing it, we have to first answer the question why. Why are we doing this? And the answer is important in governance because it establishes the basis or imperative for finding solutions. We're into big data. So in this section, we'll go over that information with an end objective, which is to evaluate resource recovery opportunities that divert from the traditional linear economy pathway. And on Guam, that pathway ultimately leads to land disposal, illegal dumping, or burning. Instead, just like the diagram shown in this slide, the objective is a green circular economy. In summary, the goal is to implement systems that are sustainable. And what I mean by sustainable, obviously, it has to be beneficial economically, socially, and environmentally. And regenerative in design so as to reduce the consumption of non-renewable resources as well as waste. Next slide. Okay, so this is the problem. This is the imperative. And at pre-pandemic conditions, so based on data collected in the 2019 Waste Characterization Study, we know that post-consumer plastic represents 25% by weight of what goes into the landfill, 25% by weight. We know the types of plastics that are being disposed. We know the sector contribution to this waste stream because we evaluated what was coming from the single homes, multi-dwelling residences, commercial establishments, military bases, and yes, dump sites. We also know which companies are the source of the plastic because we included a brand audit. Now, in the infograph at pre-pandemic conditions, 99% of post-consumer plastic is landfilled. Let me repeat, this is all pre-pandemic. 99% of post-consumer plastic is landfilled. And what little was recycled was limited to plastic resins 1 and 2. Slide 8, if we could. Why? And the more on the why, let's take a look at the cost. Recycling is good and encouraged, but the cost is high because post-consumer plastic is truly recycled off-island. And the companies have to meet the stringent standards required as part of the China Sword or transport these materials further out into the Asian countries. As mentioned in the previous slide, 99% of post-consumer plastic ends up in the landfill. The charge to residents to landfill is about $170 per ton. And if you add in the collection service, the total amount charged to residents is about $270 per ton. Now that's your revenue, okay? As you look further into this slide, recycling right now is fully subsidized. There is no additional charge to residents. So at $700 a ton as a cost, and that's for baled PET HDPE, this means that Guam Solid Waste Authority is operating at a $430 per ton loss just to operate its recycling activities. And at this junction, I'm going to have Julie Carver ask Julie to continue with the next slides on post-consumer plastic and waste tires. Thank you.
Thank you, Conchita. Now, I'm not sure if I'm actually going to be able to see your hands because there's a very bright light here. But I would like you to participate in a little survey for me, if you would. Just humor me for a second. And raise your hand. Who here today came to work or came to the symposium by paddleboarding or kayaking? Okay, I don't see any hands going up. Okay, who walked here today to the symposium on the beach? Okay, again, no hands going up. Who here today came via car or bicycle on a road? Great. Actually, can you go back one slide, please? Roadways are a central component of the world's infrastructure and present a wide array of opportunities to reuse materials. Roads and highways make up a large portion of the built environment and are essential to our everyday life. Transportation and construction industries use vast quantities of earthen materials annually to construct and maintain our road and highway networks. By replacing even a small percentage of the natural soils, aggregates, and cements used in road and utility infrastructure components with materials that would otherwise be disposed of, we start working within the construct of a circular economy by beneficially reusing a waste material and creating the potential to realize some very significant positive economic and environmental impacts. Next slide. First appearing in India 2 decades ago, plastic roads are being tested and built in more and more countries as the world's plastic problem becomes more acutely felt. The most recent generation of sustainable plastic roads have gained significant ground in the last several years and acceptance in Europe, Asia, Africa, and Australia. Several countries, South Africa, Vietnam, Mexico, the Philippines, and the United States among them, have recently, in the last 2 years, created or paved their first plastic roads. Next slide. Conchita talked a little bit about mechanical recycling or traditional recycling methods. Mechanical recycling processes work relatively well for items like water bottles, which is #1 plastic, and milk jugs, or #2 plastics. But managing the complex stream of film, chip bags, synthetic fibers, and other plastics that enter Guam's waste stream every day using traditional mechanical recycling techniques is not currently effective. Lately, there's been a significant progress in the practice of recovery, also known as chemical recycling, and increased interest in how recovery operations can move us towards sustainable plastic waste management. Recovery processes complement mechanical recycling processes where the latter proves to be inefficient or incapable of handling the waste, as is the case for difficult to recycle plastics. Chemical recycling is one of the ways that we can potentially make significant inroads into the circular economy with plastic waste. Next slide. Using recycled plastic for road building sounds simple, but it actually requires a complex process to create the right material. There are currently several methods being used to repurpose recycled plastic into roadways, and they're not all created equal. One method developed by a company in the Netherlands uses modular elements extruded from 100% recycled plastic to create a product which fits together something like a puzzle. The plastic road modular elements are prefabricated with a hollow space, which is meant to be used for drainage, cabling, and floodwater attenuation. The leftmost picture in this slide shows one of the plastic road modular element roads being placed in the Netherlands. Earlier today, you heard a little bit from Resin 8. This is another technique that is being used to create plastic roads but those are, at least to date, their roads have been plastic concrete. So traditional asphalt, which was first used in the 1870s to pave roads in the US, has historically been composed of 90 to 95% aggregate, which in Guam is coral limestone, and 5 to 10% bitumen, that black gooey substance extruded from crude oil that binds the aggregate together. In the 1990s, polymer modified asphalt, which is a standard asphalt mixture with chemical polymers used to enhance the performance of the asphalt binder, arrived on the scene. In recent years, the use of recycled plastic modified asphalt binders and mixtures, which is classified as a polymer modified asphalt, have begun making inroads in paving technology. Two different methods that I'm going to talk about today include a technique being used by McReber in the first plastic road in the UK, which was built in Scotland by 2019. McReber's method for building plastic roads involves mixing pellets made from waste plastics and incorporating those pellets as a bitumen extender into the hot mix process used to make the recycled plastic modified asphalt mixture. According to McReber's website, 1 ton of their plastic asphalt mix contains the equivalent of 80,000 plastic bottles. Dow is another one of the companies working on incorporating post-consumer recycled plastic into asphalt to create the next generation of sustainable roads. Dow is adding polyethylene-rich waste plastics, number 1 and number 2, but also number 4 and number 7 plastics, which are much harder to recycle, into mixtures used to make polymer modified asphalt. Heat and mechanical agitation are used to produce a homogeneous blend of polymer in the asphalt. The polymer then chemically bonds to certain functionalities in the asphaltene molecule, creating a much longer lasting asphalt capable of withstanding greatly increased weight loads and greater traffic volumes. According to a corporate press release provided by Dow in 2019 regarding a plastic road project that they completed in Texas, 1,700 pounds of recycled plastics, which equates to 120,000 plastic grocery bags, were used in the recycled plastic polymer modified asphalt that Dow placed for 2,600 feet of asphalt road. Next slide, please. We've got a very exciting partnership underway on Guam to undertake a demo project with Dow Chemical, which uses recycled plastic modified asphalt. Our end goal, it's to reduce the amount of waste going into Lejeune, create on-island markets for waste plastics, create green jobs for Guam, all while building sustainable infrastructure which can be held up as a model for other island nations and U.S. states and territories to emulate. Next slide. Waste tires present unique and challenging recycling and disposal problems because they are heavy, bulky, and made from a variety of industrial materials. The struggle with what to do with waste tires has proven to be particularly troublesome and quite costly for Guam due to Guam's remote location and the lack of end-use markets for this waste material on island. Some interesting facts and figures. Next slide, please. Regarding the magnitude of Guam's waste tire issues. Guam produces roughly an average of 100,000 waste tires per year, which is equivalent to 100 to 110 tons per month of waste. Although this slide does show that there is 0% on-island recovery or beneficial reuse, that is incorrect. There is less than 0.5% of reuse on the island, we do have growers on island that are using waste tires in the production of dragon fruit, so kudos go to them. In recent years, shredded waste tires have been shipped off island for use as tire-derived fuel to South Korea and Japan at a cost to Guam of $110 a ton. Both countries have signaled a reluctance to continue taking this waste material, which increases the urgency of finding a solution involving an on-island market which utilizes this resource as a valuable commodity rather than a waste, and again, moves us into the green circular economy. Next slide. Throughout the world, there are 3 primary end-use markets which utilize waste tires in the green circular economy. The most significant is the tire-derived fuel market. About 100 million waste tires are used annually as tire-derived fuel in the United States, making TDF the single biggest use for waste or scrap tires. Because oil and rubber burn well, waste tires are burned as fuel in pulp and paper factories, cement kilns, industrial furnaces, and other facilities. The next largest use of waste tires in the United States is in crumb rubber applications. Crumb rubber, which is also referred to as ground rubber, is produced by grinding mechanically or cryogenically processing waste tires into different size pieces. Crumb rubber is then used to produce new rubber products such as landscaping mulch, rubber mats, and rubber modified asphalt. In 2019, the crumb rubber market consumed 24.5% of the waste tires generated in the United States. And then the third primary market for waste tires is in civil engineering applications. The engineering market consumed nearly 13 million tires, or 5% of the waste tires recycled in the United States in 2019. Tire shreds are increasingly used instead of raw materials such as sand and clay for drainage materials in septic tank leach fields, stormwater basins, and in roadway and railroad infrastructure construction. It's also used in the construction of landfill leachate collection systems and as lightweight fill in various construction applications to prevent erosion and landslides. Outside of the 3 primary markets I've just mentioned, there are a number of other very small markets that include tires used for reclamation projects, agricultural purposes, or tires used to produce products punched, pressed, or stamped, retreads, and then of course there are some tires that are exported. Next slide. In 2019, approximately 100,000 tires were discarded or disposed of on Guam, as I previously mentioned. To give you an idea of the magnitude of the issue in the United States, 303 million tires were discarded or disposed of throughout the U.S. and its territories in 2019. Approximately 76% of those tires were reused or recycled in some way, making waste tires one of the most recycled products in the United States. Next slide. We are currently developing a report that looks at a range of beneficial reuse options for waste tires on Guam. A broad range of end-use options were initially considered based on research of case studies, industry material, regulatory guidance, and vendor information. The beneficial reuse alternatives ultimately selected for evaluation in this report that is currently being developed are listed here, and these alternatives were deemed to be the most viable alternatives for Guam to evaluate in detail. Now, some of these options can potentially be implemented relatively quickly. And when I say relatively quickly, under 2 years, while others require investment in capital equipment not currently available on Guam, or a change to standard industry practices or government regulations. Stay tuned for further developments as this report is developed. Next slide. And now I'd like to turn the presentation over to my colleague Corey Heinz from Jacobs to talk more about some of the work he's doing on waste tires.
Thanks, Julie. Good job. All right, so Julie had mentioned a little bit about the composition of the tires. A quick review: the tires are about 19% natural rubber, about 24% synthetic rubber. Then you've got fabric and steel bands and some other chemicals in there. So kind of this mixture. And as we were going to evaluate some of these alternative uses on Guam, we needed to make sure that this is going to be safe for Guam. So specifically, we needed to test the leachability. And what that means is when the rainwater contacts and moves through some of these waste tires, is there any harmful chemicals that are going to leach out of the tires and go either into the groundwater or the surface water and cause harm to humans or the environment. So as a quick aside, I couldn't help but be excited in some of the sessions this morning on the talk about flooding and flood control and someone that mentioned that they couldn't find drain rock on the island, hard to get. Well, this tire-derived aggregate, the tire shreds, can be used as a synthetic drain rock in any place where drain rock can be used. But we need to make sure that it's safe before we do this. Okay, so this is where the leachability study comes into place. So what we did is we gathered up a bunch of the tire shreds from Mr. Rubbishman's operation, and we sent them to laboratories on the mainland to get them tested. So next slide, please. So this is an overview of our testing. We did it in 3 phases. The first phase was what we called a batch soak test. We take a batch of these shredded tires and we literally soak them in water for different amounts of times, and we analyze the results. That's what we call a worst case long-term contact. The second phase was a laboratory simulated rain event where you're flowing the water through the tires at different liquid to solid ratios and doing the testing off of them. But we also wanted to test on Guam. So we did also one of these flow-through tests using actual rain here on Guam. We wanted to test the tires under Guam's water and Guam's temperatures. Next slide. So next one, there we go. So these are some photos of the different pieces of the shreds that we analyzed. When we collected our shreds for the samples, we wanted to make sure that we had a representative sample of the tires for each test. So we divided them up into categories that I'll call chunky, moderate, and thin, okay? To make sure that we had about the same weight percentage of each type. Next slide. We also looked at the percentage of the shreds that had exposed metal beads, because this is where the heavy metals comes from. So we rounded them all up and we got representative samples. Next slide. This shows some of the data that from this worst case soak test on the metals. So you see that we are getting some metals hits on most of the metals in there. And as expected, the highest results, for the most part, were in the test with the longest soak time, so the longest contact time. The nice thing that we learned about this, and you'll see a slide about this later, is that most of these results are actually quite low, and they're below, for the most part, the primary or secondary drinking water standards. Next slide, please. This slide shows our preliminary results on the organics on this batch soak test. You see that there's some organics that are coming through. Generally, though, these are also, again, low concentrations. Many of them were below the detection level. And the highest we were seeing in that 7-day soak test. Next slide. Next, we're moving on and we're testing this flow through. This is the laboratory setup. You see that the cylinder in the middle in that schematic drawing is, you'll see a shower head there. That's simulating the rain event going through the TDA, that's the tire shreds, tire-derived aggregate that's in that cylinder. And then it's coming out of the bottom of that cylinder and going into an effluent that we test. Now, you'll see the words on the top of that slide that says RCM-GAC. That stands for Reactive Core Mat, granular activated carbon. So what that is essentially is a filter. It's 2 pieces of geotextile that are sandwiching a layer of that granular activated carbon, which is used, it's a common industry method of removing organics. So we ran this water through the tire shreds using that core mat with the granular activated carbon, and then we did it with just with no core mat in there as a control. Next slide. This slide shows the field setup that we did, and you'll see in the photograph there that my assistant Frederick is holding our funnel, sort of the funnel there that's capturing the water coming out of that downspout, and it's being routed into the input to these 2 igloo coolers, and the igloo coolers are filled with the tire shreds, and one has that reactive core mat, and one does not. And so there's our control. So that was our field setup. Next slide. So here's the summary of the metals. And what I want you to focus on here, these dark lines show the primary and the secondary drinking water standards. The secondary drinking water standard is the dash line, and the primary are the solid lines there. First thing to note is that most of these metals, thankfully, are below these drinking water standards. Excellent. The manganese there is higher on that pre-soak. The other one is that in most cases here, we see that the reactive core mat also works on decreasing some of these metals. Next slide. This one shows how excellent that the reactive core mat is working to remove the organics. You can't see really any of the results except that one dinitrotoluene have been removed by the reactive core mat. Indications were in this test that DNT contaminant was a plasticizer that was coming through on the buckets that we used. But this is some good news that the reactive core mat is going to be successful in removing the organics. Next slide. So in the as we were getting into putting the testing together, we started hearing about this chemical called 6-PPD quinone that started to hit the news. And this chemical, some of you might have seen some of the articles that this is a chemical that scientists have carefully isolated that they found has been responsible for toxicity of juvenile coho salmon. And the salmon were dying, and they realized that it was near roadways, and they figured that it was coming out of the runoff, coming off of roads, and so they carefully started to test the various contaminants that they found in the runoff, and they finally isolated to this 6-PPD quinone. So we picked up on this early in our process before we had finalized our testing, and we asked Conchita if she was okay if we would test this chemical to make sure, just to check and see if it was in our tires also. Well, lo and behold, it is in the tires here on Guam, and I believe it's in every tire that's manufactured all over the world. And in our pre-soak, you see that number there, 3,800 nanograms per liter. The studies have found that the toxicity limit for these juvenile salmon was about, I believe it was 800 nanograms per liter. So we're well above that limit, and that was a sort of a shock. It's like, wow, we have that. It's in our tires, and it's also coming off our roadways. But the positive news and the good news on this is that the effluent, after we ran it through that reactive core mat, was only 37 nanograms per liter. So this is going to be an effective tool to keep that stuff out of our waterways so it does not hurt the fish. Okay? Next slide. So, last slide here, guys. These are the results and key takeaways. We did confirm that there is minor concentrations of metals and organics that are coming through with these tires. And there's high concentrations of this one contaminant, this 6-ppd quinone. But our studies clearly showed that this use of this reactive core mat with the granular activated carbon can dramatically reduce these levels. It reduces metal concentration some, and that's enough, and then it removes the organics. And for the the final recommendation for that 6-ppd quinone is that we got that nice low result when it came through the reactive core mat, but we need to do we're going to recommend some additional studies to make sure was the reduction due to going through the core mat, or was the reduction due to that initial soak? What actually reduced it? So anyway, in summary, what our recommendation is going to be for these civil engineering applications for these tire shreds is that when these are used, number one, we use in situations where these tire shreds are not going to be in direct applications that could be in contact with runoff that would go directly to our rivers or beaches or oceans. These would be below ground applications, and when these are going to be used below ground, we use one of these reactive core mats with the granular activated carbon. And these are not, this core mat is not expensive. They're manufactured in the US. I believe there's a plant on Hawaii. So this is something that is going to be feasible for us to do. So some good cutting edge research. This type of research is, there's major universities and government agencies that are doing this research concurrently. It's cutting edge, and we want to make sure that we're doing things safe before we recommend the use of these tire shreds. So with that, I think, Conchita, were you going to close out? Okay, yeah, when on the reporting, I think we probably have about another month before we can finalize all of our testing results, and probably another month after that. So I'm thinking another 2 months before the report's going to be available.
These are recommendations. So at the end of the report, like what we always do, our job is to make recommendations, present the big data to the government, and it's up to the government to make the final decision based on this big data. Now on that, let's open this up for questions. I know we're running, how's the time? We're good? We're good? Okay, we can take a couple of questions. Okay, we have one.
Going back to your utilizing the waste plastics in your roads, I wanted to ask 2 questions. Number one, so Guam's, the climate, it's nothing like the Netherlands, nothing like Scotland, nothing like Texas. So have there been any kind of case studies done as to how that material is going to hold up in this type of a climate with the salt air, the wind, wave attack?
Well, it's one of the reasons we're doing the demonstration is to look at all of that. But the project that's been done by Dow is in Houston, and the climate is remarkably like Guam's, and there's a lot of salt air. So, and that was done in 2019. Dow has a lot of data related to that that's been turned over to the regulators. I mean, we're under a non-disclosure with Dow, so I can't really discuss it, but the results look absolutely remarkable.
And then the second question is there anyone taking it to the next step and looking at the permeability? Because impervious surface everywhere and with the continued development is just going to compound that problem. And so is anyone looking at taking it to the next level and looking at pervious surfaces and reducing the impervious within these products?
Well, that's funny you would mention that. One of the products that we're looking at with respect to the waste tires is a permeable paver. And I mean, this is all coming together with recommendations that we look at over the long term. And this permeable paver in the waste tire report could absolutely be used to replace some of the asphalt on Guam and address that very issue that you're talking about, as well as using tire-derived aggregate as its drainage layer. That has been tested by about 25 different Department of Transportations in the United States with, again, some pretty spectacular results.
Sorry, and that's another demonstration, fingers crossed, that's another demonstration project that we have lined up too. Oh, Brian.
Yeah, just a question about the reactive core mat. How long do you anticipate that would function? Because, you know, it relies on GAC, and we all know that GAC becomes saturated in the natural environment pretty quick, and then you have breakthrough.
Yeah, it's a good question. It's my understanding that it's the initial flush, once you put the tires in the ground or into any application, that is going to have the highest concentrations of your metals and your organics. So as long as that core mat catches that highest concentration coming down through that initial flush, after that, the need for it is going to really tail off. We've also understood that once these tires are in a sort of a wet environment, there's biofilm that forms on them, and after that film forms on them, you see, you know, essentially nothing coming off the tires. But it's a good question. Thank you.
I have a question about recycling the tires. As I recall, maybe 30 years ago or more, there was a local company that was recapping or retreading used tires here and couldn't get enough supply to economically keep going. But is that still a possibility that we need to look into more, recapping?
I think it is a possibility. It's something that we did look into, and you know, that is, you know, the height of recycling tires. I completely agree. Do you have any more on that?
I think you nailed it. The economics of retreading 30 years ago just weren't there, is our understanding. And after talking to some of the tire shops here, we believe that's still to be the case. So a lot of things have come down in price, including tires. And so that competes with things like retreading.
We'd love to see it.
Any other questions? Okay. And on that note, I think we have Ginger, the lovely Ginger Cruz, to close off us. Thank you very much.
Let's have a round of applause. That was a great presentation. Thank you. And I got to tell you, I mean, when you're a geek at heart like me, this stuff is super interesting. And it's kind of amazing to see, after all of these years, the technical advancement and all of the new opportunities to do things that could be so useful on Guam and that could really change people's lives, help the environment, and do our part. So it's been an honor to be part of the program here. I'll tell you, this was an interesting day, and I really thank all of you for hanging in there. You've all been wonderful. We're going to have a little bit of fun in the afternoon, but before we get there, for closing remarks, I would like to once again introduce the erudite director of the Bureau of Statistics and Plans, Tyrone Titano.
Thank you, Ginger. After a comment like that, you see why I asked her to be the MC. So first of all, I want to thank you all for participating in this important first day. My deepest thanks to all the presenters today who have brought something really valuable to this assembly. It's not over yet. We start another day of the Assembly Planners Symposium tomorrow with the registration beginning at 8:30, and at 9 o'clock, you get to hear from me again as I welcome you all to the second day and introduce, to give opening remarks, the Honorable Joshua Tenorio, Lieutenant Governor of Guam. Tomorrow we'll focus with our partners at Primo on natural disaster recovery and opportunities from the American Rescue Plan, and also breakout sessions on designing recovery plans. And so it's still an important and fruitful agenda. Just to thank a few people at the end of this first day, I want to thank our erudite Mistress of Ceremonies, Ginger Cruz, the engineer who's kept the train moving along and has yet nothing plus year, including falling behind on time and anything else. So thank you, Ginger, so much. You know, we've done this all while wearing a mask. So thank you, Ginger. And I also, of course, need to thank the staff of the Bureau of Statistics and Plans, in particular Edwin Regis and his crew on the Guam Coastal Management Program, all of whom have contributed to making this day possible, either by staffing this event here or working late last night putting together badges so they could be done in all range of stuff, including staff support back at the office. So please join me in giving another round of applause for the staff of the Bureau of Statistics and Plans. You know, I've done a number of interviews about this event, and just to get to the core as to why we do this. And why we do this is like basically two things. One, we're trying to create a sort of a crucible of information and decision making here that ultimately leads to solutions. This event will be meaningless if it's not utilized to actually solve the problems out there. The other reason why we do this is to bring the community into this process. When you examine some of the issues that have been addressed today, climate change, land use planning, coral reefs that have been touched on. When you take a look at those issues, these are not the sort of issues or problems that are going to be solved by any single government agency, or for that matter, any single government. It's going to be solved with partnerships with academia, with the federal government. It'll be solved by a community. And the more we get the community involved in this process, the better we will to move it along and actually solve these problems. So again, I want to echo a comment made by Governor Leangro this morning. I want to thank you all for your participation, either in person or virtually, your participation to be part of the solution, which I think we've made substantial progress with today. Again, thank you all. See you all tomorrow, either in person or Zoom, for another, I think, very interesting day for the 6th Annual Assembly of Planners Symposium. Thank you all very much.